Today we will learn how to solve systems of linear equations, but graphically. So there are three possible cases, either to have one solution, no solution, or infinite many solutions. Let's look at the first case, when we only have one solution. So if we were to graph the lines representing the equations given in the systems of linear equations, we might find that one of the lines looks something like this, and another line looks something like this. So here we see one point of intersection. That means that there is only one solution. But of course our lines can look differently. So maybe it could look something like that, or kind of like that. And so there are a lot of possible ways that you can have your lines. But all of these four cases that I have shown only have one solution. Why? Because in the graph we only see one point of intersection in each one of them. However, sometimes it's kind of hard to graph, or before graphing you want to know if there's only one solution. So in order to know that, we will note some things that are special about the slopes x and x or y intercept of the system of linear equations. So the slope of the equations must be different always if you want to have only one solution. Also, the x or y intercept, the or means that it can be either one or both, must be different as well. And when you look at the graph, you only see one point of intersection. So if you see these three things together, then you know that you only have one solution for the system of linear. For instance, if we look at our four examples that we had previously, we can see that for the first one right here, both slopes are different, of course. They're quite opposite. Then we have also the x-intercept is different and the y-intercept is different. So as you might recall, you don't have to have both different, as long as one is different is enough, but in this case we have both of them different. In the next case, we have our x-intercept, which is different, our slope is different, our y-intercept, this black line crosses the y-axis, the blue one doesn't, so that, like by itself, means that the y-intercept is different. So in this case, we also have the x and y-intercept being different. Next, even though our y-intercept is the same right here, it seems that they cross at 4, both of them, the x-intercept is considered to be different since the black line crosses the x-axis and the blue one doesn't. And of course the slope is different in both cases, and same thing here. Even though our x-intercept is the same, our y-intercept is quite different and our slope is different, so we know that there is only one solution. Now the next case is to have no solutions. When you have no solutions, your graph will look something like this. So one of the lines will maybe look something like that, and the other one must be exactly parallel to it. It doesn't matter how close or how far, as long as it's a parallel line and it's not the same line, you will have no solution because there is no point of intersection. So in the slope is going to be the same because they must be parallel. The x and y intercept, both of them must be different. And in the graph you see no point of intersection. Also known as parallel lines. So last, it's to have infinite many solutions. That means that if you were to graph one of the lines like that, the second line would be just on top of it, exactly the same line, right here. And as you know, they go to infinity, both of them. So that means that the slope must be the same because they are basically the same line. The x and y intercept must be the same because they are basically the same line again. And the graph looks like just one line because they are the same. So those are your three cases. I hope this helped. Thank you.